In this video, we will solve some logarithmic simultaneous equations, IGCSE math. Okay, so let's get started with question number 6, part A. So we have this equation that we are supposed to, simultaneous equation that we are going to find the value of x and y. Since there is no enough space here, I will copy and solve it below here. So let me write A, which was a simultaneous equation. X times y is equal to 64, and then log y to base x is equal to 2. Okay, then simply we can convert this logarithmic form to an exponential form. I can write it like x to the power of 2 is equal to y. Then we have got two new simultaneous equations, and they are this: x times y is equal to 64, x to the power of 2 is equal to y. Okay, so then I'm going to solve this problem, and then here I will replace the value of y by x to the power of 2. Then it will be like, so if I replace it in the equation above, then it will be x times, instead of y I will write x to the power of 2 is equal to 64, and then it will be x to the power of 3 is equal to 64. So it will be like okay, so then therefore x will be equal to 4. Okay, then again replace the x with its value in one of those equations, and then I will find the value of y, and I will write like so. Therefore it will be in equation number 1, x point y, in equation number 1, x times y is equal to 64. I have found the value of x. I will write it here. 4 times y is equal to 64. Therefore, the value of y will be equal to 16. So this is the value of x and the value of y. This is part A. Now let's move on to part B. Okay, another simultaneous equation, and we are going to find the value of x and y. So that will be b 2 to the power of x is equal to 4 to the power of y, and another one, 2 log y is equal to log x plus log 5. Okay, so we have these simultaneous equations, and we are supposed to find the value of x and y. So then I will use the logarithmic equations properties, log y, and I will move this coefficient 2 as a power 2 here to y is equal to log x times 5. Okay, then here we can conclude that since the basis of these two logarithms are the same, therefore these numbers must be the same. So therefore we can conclude y to the power of 2 is equal to 5x. This is the conclusion we can draw from this equation. And another one here, we can write it like 2 to the power of x is equal to 2 to the power of 2. Instead of 4, I will write 2 to the power of 2 all to the power of y, which is equal to 2 to the power of 2y. Okay, so here see we have an equation, one side is 2 to the power of x and another side is 2 to the power of 2y. Bases are the same, powers must be the same. So therefore I can conclude here x is equal to 2y. So now let's see what we have got. We have changed this simultaneous equation to here, to this equation. X is equal to 2y and y2 is equal to 5x. Okay, this is what we have got. So then we can easily now solve this simultaneous equation, and it will be just substitute one from the other equation. So it will be y to the power of 2 is equal to 5 times 2y instead of x. Yeah, and then therefore y will be equal to 10. Okay, and if we substitute y by 10 in one of the equations, we can get therefore x will be equal to, from equation number 1, 20. Okay, so this is the value of x. Now we will move to part C. So we have got here part C, log x plus y to base 4 is equal to 2 log x to base 4. Okay, and also log y to base 4 is equal to log 3 to base 4 plus log x to base 4. So remember, here we are supposed to find the value of x and y. So from the equation above, I can just simply say that log x plus y to base 4 must be equal to log x to the power of 2 to base 4. This is the property of, one of the properties of the logarithmic equation. I can change that. Okay, then here we can conclude that because these two values must be the same since their logarithm are the same. Okay, so therefore x plus y must be equal to x to the power of 2. This is one equation I can draw, and another one here I can simplify it by using the properties of logarithm, and I can say log y to base 4 is equal to log 3x to base 4. And then here also I can conclude that because the bases are the same, so the values must be the same or equal. So therefore y must be equal to 3x. This is another simplified equation I can draw from this logarithmic equation. So therefore let me rewrite it here very in an organized way to avoid any confusion. So it will be x plus y is equal to x to the power of 2. This is one equation, and another one is y is equal to 3x. Now I can simply solve this easy simultaneous equation, and here I can just substitute the value of y by 3x, and I can get x plus, instead of y I will write 3x is equal to x2, and then I can simplify these x's together, and then it will be equal to x is equal to 1 plus 3, which is equal to 4. So x will be equal to 4. This is one of my findings. and another one I will replace 4 in this equation, and I can find the value of y, and then therefore y will be equal to 3 times 4, which is equal to 12, and that is the value of y. Okay, now let's move on to part D, which is another simultaneous equation. I will rewrite D here. D says x times y is equal to 640, and also 2 log x to base 10 minus log y to base 10 is equal to 2. This is the simultaneous system, two equations. So therefore I can simplify this one easily using the logarithmic rules and properties. I can write log x to the power of 2 to base 10 minus log y to base 10 is equal to 2. Okay, and then I can say log x to the power of 2 to base 10 minus log y to base 10 is equal to, instead of 2 I will write 2 log 10 to base 10, because log 10 to base 10 is equal to 1. So the next step, I will move this 2 as the power to 10, so then I can write it again. Therefore log x2 divided by y, because this is subtraction, so I can change it to division, to base 10 is equal to log 10 to the power of 2 to base 10. So the bases are the same, and the values of logarithm must be the same. So therefore I can conclude here that x to the power of 2 divided by y must be equal to 100. Okay, so this is one of the findings. So let me rewrite it again here. What we are going to do, we will be solving this simultaneous equation. X to the power of 2 divided by y is equal to 100. Okay, so then we can find the value of one of these variables and just replaced that value in the equation above, one of them which is simplest. So let me find the value of y, which is equal to x to the power of 2 divided by 100, and then I will substitute y here. Okay, so therefore it will be x times x to the power of 2 divided by 100 is equal to 640, and then it will be equal to, which is equal to, therefore x to the power of 3 divided by 100 is equal to 640. So therefore I can say x to the power of 3 is equal to 64,000. Okay, and that will be like okay, and that will be x 40. Okay, so this is the value of x, and then I can replace x to one of the equations above, and I can find the value of y, which is 16. Okay, so these are the answers. And next one, which is E, I will write E here. E log a to base 10 is equal to log 2 times log b to base 10, And also another equation is log 2a minus b to base 10 is equal to 1. So this is a system simultaneous equation, two equations, and then we are supposed to find the value of a and b. So here we are going to find the value of a and b. Okay, so here I can easily I can simplify by using the properties of logarithm, and I can say log a to base 10 is equal to log b to the power of 2 to base 10. Therefore, I can conclude a must be equal to b to the power of 2. So this is one of the simplified equation. And another one, I can write log 2a minus b to base 10 must be equal to, instead of 1, I will write log 10 to base 10. Therefore, bases are the same, so the values of logarithm must be the same. So therefore, we can conclude that 2a minus b is equal to 10. So this is one of another findings. So let me rewrite them in an organized way. Here again, a is equal to b to the power of 2, and another equation which is 2a minus b is equal to 10. And now I will substitute the value of a by b to the power of 2. Therefore, this equation will be equal to 2. Instead of a, I will write b to the power of 2 minus b is equal to, so instead of equal, I will move 10 to the left side of the equation, and here we have got a quadratic equation now. Okay, and we need to solve this quadratic equation here. We need to solve it, and then by solving it, it's quite easy. We can get two values for b. One b will be equal to 5 over 2, and another one b will be equal to negative 2. So we will not accept negative value, we will take the positive one, and therefore b will be equal to 2.5. Okay, then we can substitute b to any of these equations, and we can find therefore the value of a, which will be equal to 6.25. This is the value of a. Okay, now let's move on to f and solve f. I will write f here again for you. F will be 4x times y is equal to 2x plus y. Okay, this is one equation. Another one is log y to base 2 minus log x to base 2 is equal to 1. Okay, and here we need to simplify first to find the value of x and the value of y. We need to find the values of these two variables. So simply I can here say immediately that I need to convert these two bases. I need to make these two bases similar. So therefore here is 2. I can but simplify 4 also. I can make it to 2 to be to 2. So therefore I can write 2 to the power of 2xy. Yes, and 2 to the power of 2 to the power of x to x and y, because x and y then can be multiplied by this 2, will be equal to 2 to the power of x plus y. Therefore I can conclude bases are the same, powers must be, or indexes must be the same. So therefore I can conclude this equation to x y is equal to x plus y. This is one of the conclusion. And another one here, I can write log y to base 2 minus log x to base 2 is equal to log, instead of y I can write log 2 base to base log 2 to base 2. Then I can write log y divided by x to base 2 is equal to log 2 to base 2, which I can conclude here y divided by x must be equal to 2. This is another conclusion. So then let me rewrite them again here, tidy and neat, so I can understand what I'm going to do. So this will be 2x y, 2 times x times y must be equal to x plus 5, and also y must be equal to 2x. Okay, so therefore I can put the value of y and replace it by 2x, and I can get this equation 2x instead of y, again 2x will be equal to x plus y. Okay, and then we just simplify, it will be 4x2 minus x minus 5 must be equal to 0. So this is another quadratic equation. If we solve it, we will get two values for x. One is 1.25 and another one is -1 values for x, which we will not accept the -1 and we will take the positive one, 1.25. so this is the value for x, and then I can substitute it in this equation, and I can say y is equal to 2 times 1.25, which is equal to 2.5, and this is the value of y. Okay, so this is part F. We have solved now question number 6 from A to F. Now question number 7 says show log x to the power of 2 times y to base 10 is equal to 18. This can be written as here 2 log x plus log y is equal to 18. This is part A. Part B, we need to find the value of log x and log y. So here is not anymore finding the value of x and y. We need to find the value of log x and log y. Okay, so I will rewrite it here down below this solution. So this is question number 7. Question number 7, part A. Part A, we need to prove. So this is log x to the power of 2 times y is equal to 18, and we need to prove it. How we need to show how we can write it in this form: 2 log x plus log y is equal to 18. And it's quite simple. So we can write simply log x2 plus log y is equal to 18. Okay, and then I will convert, and then I will move this power behind the log, because this is one of the properties or the rules of logarithmic equations. So I can write it like 2 log x plus log y is equal to 18, and this is what we were supposed to prove. Okay, so that is the proof. Part B, we have two equations, log x to the power of 2y is equal to 18, and another one is log x divided by y to the power of 3. So let me write it again. Log x divided by y to the power of 3, okay, is equal to 2. And then we are supposed to find the value of log x and log y. Find the value of log, okay, not the value of x. So then simply I can rewrite equation. Let me write here equation number 1, and this one is number 2. So I will simplify from number 1. Let's simplify from number 1. Okay, so I can write it in this way. I can write it like as I proved above. So I can rewrite it again here. 2 log x plus log y is equal to 18. Yes, this is what I can write. And then the second one, I can rewrite it like that. Log x minus log y to the power of 3 is equal to 2. Okay, and then again I can simplify it further because there is a power here, and this power is not what I want, because the rest of the logs are simple, they don't have any power. So therefore again I will write it. This time is like 2 log x plus log y is equal to 18, and another one log x minus 3 log y is equal to 2. Okay, so now here we can simply see that it's quite easy to find the value of log, because I can easily multiply this equation by the value of -2. I can multiply this both sides of the equation by -2, and then I can rewrite this equation again in this way. So it will be 2 log x plus log y is equal to 18, and here it will be -2 log x plus 6 log y is equal to -4. Okay, and then it will be cancelled out. By solving this, by simplifying, we can get to this point, log 7 log y is equal to 14. Then we just need to add them up, and then we will get log y is equal to 2. Okay, so we found the value of log 2. Then I can replace in either of these equations, and then I can find the value of log x. So therefore I can simplify. Okay, then I can say 2 log x plus, I will choose this one, okay, plus, instead of log y, I will write 2. 2 is equal to 18, and therefore log x will be equal to 8. Okay, and this is the answer. So we found already the values of log x and log y for this question number 7. Alright, thanks for watching this video, and please like and subscribe if you found this video helpful.